Today I want to talk to you about Windows DHCP server again, and that is in the last series we are talking about how to configure IP class fabric, where loopback is a source for DHCP relay. And in this case I wanted to bring an example that happened to our customer, which is running Windows DHCP server. Now, as Windows basically state, you have to, if we look at the DHCP server, you have to enable option 82 sub option 5 if your gig address, which is the gateway IP address, isn't basically the one communicating and part of the DHCP request. So the scenario is if the client belongs on an existing subnet and he's moved to new subnet. That could be because he's roaming on the same SSID between access points, and those access points are connected to different switches. Or, for example, if there is a missed NACK or any other network access control and move the client to different VLAN due to .1x, right? So what basically happens is the client sends the DHCP request because he already has an IP address and would like to renew the new IP address, right? Once he's on a new VLAN. So it is requesting 10.32.32.100. As you can see, that's the requested address. And to the DHCP server, the switch relays also automatically option 82 sub option 5, which is link selection. That's supposed to tell the server per Microsoft documentation which subnet is the client on. Now I will have all of these links in our reference. Now, if you can see, is the client is renewing 10.32.32.100, right? The DHCP relay, in this case, or EX switch, is sending option 82 sub option 5, as you can see, but it's 10.33.33.1, which is a different subnet. And the server sending back acknowledgement, okay, yes, you can have 10.32.32.100, while the client is obviously on a wrong VLAN. So what will happen is the client has a IP address that cannot reach this default gateway and he won't be able to communicate with anything. I can show you in real example how that happens. So if you look at the Microsoft documentation, right, it basically says that it's now supported in the Windows 22, 2019 and 2016, right? And the gig address must be configured as a DHCP scope and so on, right? So let's get into it and let's see what really happens. So in this case, this is our switch. We can see that the switch is on configure, it has a .1x. The user is called restricted. All right. The user is restricted. And there's VLAN 1032. If we look at the show VLANs, we'll see that on VLAN 1032 we are on G00, right? We're not on VLAN 1033, so that's where the client is connected to. Now the client is right here. This is the client. Now I also have a packet capture that we can do. This is just the screenshot, but real life packet capture is right here. Let's refresh it. And right here, this is the client. And let's refresh it again, right? So we can see now I'm also ARPing, but let's remove the ARP from the current filter and refresh it. Right? And I'll make it a little bit bigger so it's easy to see. So we go back to the client, and you can see the client is associated with VLAN 10.32.32. This is the client, so over here we can hopefully we can run DHCP client renew, right? So this is a verbose. So the client is requesting 10.33.33.100, right? And has an acknowledgement. You can go ahead use it while the client is connected on 10.30 on VLAN 10.32, not on VLAN 10.33. So if you're gonna take a look at our packet capture, right, we can see that this is the server, if I'm not mistaken. This is the server, this is the client. So the client sends request. Hello, it's if you look, it is sent to anybody, right? It's a broadcast. The destination is a broadcast, right? It's intercepted by the switch relays it and sends it to the DHCP server. So if you look, this is the DHCP server part, and this is the request. You can see that it's coming from 172.16.197, and this is most likely 13, right? So we can see that it's coming from 13. Now if we go back to our switch, we do show configuration interface back 0, display inheritance no. You can see that, well, this is our loopback, and it's assigned to that VRF where the client is assigned. So in this case, move this way. In this case, we can see that it's coming from that IP address. The client is requesting, this is the relay agent, the client is requesting, I want to have a 10.33.33.100. We're correctly passing option 82 sub option 5, which is the link selection. And you can see we're informing it, hey, we're on 10.32.33.1, but the server is literally disobeying that and sending client acknowledgement. And that is the problem, right? Even though Microsoft says that's all what you need. Well, there is a bug in those DHCP servers, and if you look at my DHCP server is basically patched. If you look, just system, there's system somewhere, oh, right here, system, and we'll scroll on about our server is what is it? It is a Windows 2019 standard server, right? I still have some days left, 128 days, and I'm pretty much good with the patches. If we check the update and security, Windows update, I do have few, but nothing major, right? So Adobe and that's pretty much it, right? Nothing major. Well, yet it still does not work, right? Now the issue with that is the server is ignoring it. So to fix that, and I'll paste an article again, is we need to modify a Windows registry on the current control set for the DHCP and create a new flag that's called DHCP flag subnet change DHCP request, which basically stands for, well, if there's a sub option 5 and an option 82 specify, please use that, right? So that's that will tell what IP address the client's supposed to be in, right? It's obviously it's not been very well implemented. Now, if you look at our DHCP configuration, show configuration display set match DHCP match 1033, or we can do 1032, right? 1032, we can see that this is our configuration. We're using loopback 5, which is right here above as our source, and we're specifying server ID override. Now, if we take a look at this command, server ID override, we're also passing. If we take a look, there's a server ID override in this request. If we scroll down, option 82, right, option 82, there's a server ID override which also states 10.32.32, but that's something else. This is for any communication, use the relay as the source when transmitting packets to the client. So the client will only talk to the DHCP relay, but not directly to the server, right? The server will basically not reveal the IP address. That's what this is. But in that, underneath the same command, there is a default link selection, right? So if we go to configuration and we pasting the command server ID override and do question mark, you can see that there's a link selection, right? Link selection, send link selection sub option packet to the server. Now this is applied by default, so you don't have to specify it. It's been there since 22.3, I believe. So it hasn't been there forever, but that's basically it instructing automatically to send that option. So if we patch this and we implement this flag and we change the flag to value 1, and we will need to restart the services, right? So come here and we're gonna restart our servers, restart the DHCP server. We're gonna try to redo the test. We should still have our packet capture running. Alright, this is just the inform session. This is on the client, right? This is inform session, this is on the client. And if we enable ARP, you can see the client it's still on 1033 because it's been issued 1032, but it's ARPing, it's been issued go ahead, use 1033. So it's trying to ARP for its default gateway, but it cannot find it because it's on a wrong VLAN. Right? So if you remove the ARP from the filter and we're just focusing on 1032, right? You can see the requested address, it was issued, yeah, go ahead. So let's go on a client and let's redo the test, right? So we're gonna do renewal and then try to make sure what we're sending. It's gonna send the request for 1033.33.100 because that's what it currently has, right? But the server now, because it's correctly understanding what the option 82 sub option 5 does, which it should from the start, should send NACK, and then the client will, after receiving, will send a discovery and will be assigned the correct subnet. So let's see if this is now working. Right, so you can see it's requesting 1033.33.100. The server sends back DHCP NACK. You cannot have that. So the client runs discovery and it gets a correct offer now on 1032.32.100, right? So when a client receives 1032.32.100, and we can see that in a packet capture, right? So this is on the server, if I'm not mistaken, right? This is actually on the server. Request, right? It's requesting, this is on a client, apologies, 1033.33.100, right here. But it gets getting acknowledgement, so it sends discovery. The server responds, okay, you can have 1032.32.100 because that's on that correct VLAN. Now on a server, this is the request coming in, 1033.33.100. The server says no, you cannot have 1030. It requested 1033.33.100. It tells him no, you cannot have 33 because the DHCP service identifiers 1032.32.100, right? So it's basically telling client, okay, I'm your server. So the client sends discovery, it gets relayed again by by our switch. The switch keeps sending 82 sub option 5. The server sees it, offers the correct subnet, in this case 1032.32.100. The client requested, right? Basically we call it DORA, discover offer request and acknowledgement, and then basically acknowledges, and then it does that one more time, right? So that's pretty much it. So what do we have here? So this is 32.32.100 offer request acknowledgement, right? Now, this is Ubuntu. So what we are seeing a few things, and that is with Ubuntu, because if you look, we have 10.32.32.100 on it, right? Configure, which is the correct IP address. And if we ping a, well, hopefully we might be able to ping 2.1. Yes, we can ping. And the reason why we cannot ping 8.8.8 is because we have a dynamic access list. So if you do show configuration, show, is it show .1x interface detail, you'll notice this is .1x and we are permitting 1.1 pinging. This is dynamic filter. We are denying anything else and we are applying tag 303. If we look at show EVPN database, we can see for MAC address, which is 50.0D001, 0D001, you can see it here. This is our IP address, right? And show Ethernet switching table, and you can see we have a GBP tag 303, and it's connected to G000, which is corresponds what was basically given to the client. And that's pretty much it. So in this scenario, we saw that we got the correct IP address, right? And we try to we'll see that we're requesting 10.32. So now let's move the client again to 10.33.33, right? In this case, I'm gonna use the NACK. In this case, it is Cisco ICE, and I'll modify the policy, which is this policy, and you can see it in different session. So this is the client restricted, and I'm gonna move it, and I'm gonna assign different profile. Instead of a 10.32, I'm gonna assign 10.33 and remove 10.32. Right. I'll save it. I'll go back to the switch, do show .1x interface detail. We can do refresh 5. So in this case, this will refresh. We come here and we can issue change of authorization for that client. So we can do it with a port bounce. It's just the UI for ICE is not really, well, it has some parts to be desired, right? So I'm gonna click on the nest, and we can issue session termination with port bounce. Once we bounce the port, the client will basically try to send a DHCP renewal for the old IP address. So let's clean up our packet capture so it's easy to see. Continue without saving and continue without saving. So this is a server, the other is a client. So when we do issue, with a port bounce, this happens, we go to our switch, we can see we got de-authenticated, right, on that port. And the client will pass an authentication again, it gets authenticated again, and we'll see correct VLAN to be assigned. So as you can see, it's now VLAN 10.33, and it just has a GBP tag, right? So it's no longer a VLAN 10.32. And in our capture, we should see this is the authentication, right? You can see this is the authentication. And then the client sending a request and it's receiving acknowledgement. So if you look, the request is coming from 10.33.33.100. We can quickly look at option 82, right? and that is correct, right? The client's requesting 1033.33.100, and the link selection is correct, which is 1033.33.100. So the client is able to receive it. So I did a mistake. So it is on a VLAN 1033. We need to move it at VLAN 1032. So now on VLAN 1033, we need to move it to VLAN 1032. Remove this one, right? So it's just VLAN 1032, and save it. In this case, now we're gonna see it. We just need to clear out. We'll see it again. Acknowledgement. We'll restart it. Continue without saving. Continue without saving. And now we can start it and re-authenticate the user. Session termination with port bounds. So it was on VLAN 1033. Now we should move to VLAN 1032. The authenticate, there's no current applicant, so now we're on VLAN 1032. And we can take a look. This is the server. We're receiving NACK. The client sends discover, we offer correct address, we basically and we acknowledge it. And then there is a request, and this is for this is a request for address 1033.100, and we're sending back NACK because you're on VLAN 32. So I believe the issue why we're seeing also NACK is that is on a client, because if you look on our IP addresses, we'll have a board. We have 1032, and we have 1032, and we are at VLAN 1033. So we got a correct IP address, because when we first requested, we requested 1033. Collapsed. Client address 1032.100. On 1033, on 1032 we send NACK. This is discovery, offer, request, acknowledgement. Then it's requesting again 1033, but it's on 1032. So it's a negative acknowledgement, and it just basically client does that twice. For some reason, after it went through EAP, which is the EAP over here. It sends the request, gets NACK, sends discovery, gets acknowledgement, and for some reason sends request for the old address, gets NACK again, and then it just keeps the correct address, which is 1032.32.100 get out offer by that server. And that would cover these use cases, and the whole thing was this simple DHCP flag subset. And that's it. So thank you very much for watching, and have a good day.